Alright kids, last one for this unit, okay? Skill 2-9. It is over adding and subtracting radicals, okay? When we add and subtract radicals, it's very similar to when we add and subtract fractions, okay? What has to be true there is you have to have a like denominator. That's the only way you can combine the two fractions. What's true about radicals is you can only combine like radicals. So go ahead and make sure you have this down. Only combine like radicals. Okay? Only combine like radicals. Okay? So what we mean by like radical is the same number is in the inside of the radical. Okay? So for example, the square root of 2 can be added with the square root of 2. That is okay. Okay? So we'll put okay. So square root of 3 plus square root of 7, not possible because these numbers aren't alike, so they're not like radicals. Therefore I'm going to circle them, cross them out. Alright, no next to it. Not good. Okay, like radicals, same number, I can add those together. Not the same, I can't add. Okay, so let's go ahead and actually do an addition problem. So the example we're going to work through together is 3 plus the square root of 28 plus 2 times the square root of 63. Okay, so your first thought that's coming to your head right now is, well, 28 and 63, they're not alike, so we can't add them. Well, not quite sure. Can we make them like? Can we simplify these radicals and then see? Okay, so your first thought is simplify, simplify, simplify. Okay, I take a look at this first one. All right, I've got 3 sorry, don't like that color. 3 and the square root of 28. Is 28 a perfect square? No. Is there a perfect square that goes into 28? You bet. 4 goes into 28, so this is 3 times the square root of 4 times the square root of 7. Alright. Well, if we take the square root of 4, you bet. It becomes 3 times 2 times, well, can I take the square root of 7? No. So we bring it down. 7 is neither a perfect square nor a perfect square that goes into 7. Okay? So 3 times 2, that's 6 times the square root of 7. Alright. Can I simplify this anymore? I can't. Okay, so the first step you're looking to do, if you're looking to simplify all radicals. So we've done one, we still need to do another. So I'm going to go ahead. I'm going to make this plus sign red to kind of show, okay, this is where we started, this was our second part, just to separate those two. Alright, so I'm here, 2 times, well, can I simplify the square root of 63? 63 is not a perfect square, but there's a perfect square that goes into 63. And the largest perfect square that goes into 63 is the square root of 9. Square root of 9 times the square root of 7 is equal to square root of 63. So again, I'm looking at this. Can I take the square root of 9? You bet. It's 3. So I have 2 times 3 times the square root of 7. Okay? Well, I can combine the numbers on the outside together. So I've got 6 times the square root of 7. Because I already know the square root of 7 is not a perfect square, and there's no perfect square that goes into 7. Therefore, it's 6 times the square root of 7. Alright? And again, you cannot combine the outside with the inside. They both have to have radicals in order to do that. Alright? So if I continue to bring my plus sign down here, okay, I look at this. You remember, you can only add like radicals. Well, this is radical 7, this is radical 7. Are they like? You bet. So then, who I'm going to add is the outside values. Okay? These are the two numbers I'm going to add. And then this guy right here will be my final. Okay? So I know my last part is radical 7. Okay? It's like, say, radical 7 was a fruit. We'll say radical 7 is the same thing as apple. Okay? I have 6 apples here. I'm adding 6 more apples. How many do I have? 6 plus 6 is 12 apples. Okay? So you're not adding the square roots, you're adding the numbers outside the square roots. That's the key thing. I would write that down. Add the numbers outside the square root. Okay? We'll put only add. Only add the numbers outside the square root. So we added the 6's, but not the 7's. Okay? So let's go on to the next problem. I know there's a lot of information there. Again, when you're watching the video, ask questions if you got confused at any one of these points. Okay? So, next one. We have 6 times the square root of 5 minus 4 times the square root of 25 minus the square root of 20. So again, the first step is simplify all the radicals until you can't simplify no more. Okay? So, before I want to do that, I want to change this subtraction problem into an addition problem. Okay? So this becomes an addition sign, I change what follows. This becomes an addition sign, I change what follows. Okay, so I now have 6 times the square root of 5 plus negative 4 times the square root of 5 plus the negative square root of 20. Alright? So, take a look at this first one. Can I simplify 6 times the square root of 5? No, I can't. So it stays the same. Alright? This one is okay. That one's simplified. Alright? Move on to this guy. Square root of 25. Can I simplify that? First of all, you guys said first question. Is 25 a perfect square? You bet. So I have 4 times, well, the square root of 25 is 5. So my new guy right here is 20. But more specifically, this was a negative 4, so this makes it a negative 20. Okay? And then I'm going to this guy. Well, this is the negative square root of 20. I know my final answer there is going to be negative. So now I just got to worry about simplifying it. 20 is not a perfect square. However, there's a perfect square that goes into 20. That's the square root of 4 times the square root of 5. Square root of 4 is 2 times the square root of 5, because 5 is as far as it goes. Okay, so my new problem that I have is 6 square root of 5 plus negative 20 plus, oh, I forgot. Remember this was negative, so there should be a negative out in front of here. Negative, that makes this a negative 2 times the square root of 5. Okay? Well, what's nice about addition is you can change the order. We've changed this to an addition, so now we can change the order. Subtraction, you can't change the order. Okay? So I'm going to put my like radicals by each other. Well, square root of 5 is going to go with square root of 5. So I'm going to just move this negative 20 out front. So I have negative 20 plus 6 square root of 5 plus negative 2. Plus negative 2 square root of 5. Okay, well, can I add this negative 20 with anybody? No. So again, it stays negative 20. It doesn't have any other like numbers to add to it. Okay. Well, I have two things that have square root of 5. Okay. So I'm going to add the numbers outside of the square root. I'm going to add 6 and negative 2. Okay? So we go back to our first skills we did in this unit. 6 plus a negative 2 is going to equal a positive 4. So that's going to be plus a positive 4. And again, we do not add the radicals. They stay the same. Square root of 5. There is our final answer. Okay? So again, just to review what happened. First, we changed the addition, the subtraction to an addition. Okay. Then we simplified each radical. Okay. That one was simplified, so it was okay. The square root of 25 got simplified down to 5. Multiplied those. Square root of 20 broke it down into a perfect square. Okay. Then we added the like radicals. That's very, very important. You can only add like radicals. Okay. So, with that, I want you to go ahead and try these two on your own. Negative 6 times the square root of 48 minus a negative 3 times the square root of 12. And then you're doing negative 32 plus 3 times the square root of 200 minus 5 times the square root of 72. So again, use your notes from the previous two examples to help you simplify these expressions. So go ahead and pause the video and begin working on those. All right, so you've just completed those two examples on your own. Let's go through these together. All right. So we have the negative 6 times square root of 48 minus a negative 3 square root of 12. So again, the first thing we want to do, we want to change this to an addition, which that makes this a positive 3. So this is now plus 3 times square root of 12. Okay. Now we need to simplify. Okay. So this is negative 6. 48 is not a perfect square. The largest perfect square that goes into 48 is 16. 16 times 6 times the square root of 16 times square root of 3. Again, 3 times 16 is equal to 48. That's why we can break it down into those two right there. Well, the square root of 16 is actually 4. Negative 6 times a positive 4 is a negative 24 times the square root of 3. Okay? Now we need to break down this guy. So, I'm going to make room. I'm going to put my little addition sign in red here just to show that barrier. Okay? So I have 3. I'm looking to break down the square root of 12. Well, 12 is not a perfect square. However, 4 is, and it goes into 12. 3 times the square root of 4 times the square root of 3. Well, the square root of 4 is 2. And again, when I use the square root on the 4, it disappears. That's why we get the 2. Times the square root of 3. Well, we can do 3 times 2. That's 6. So 6 square root of 3. Again, I'm going to add those two values. Okay? And in order to add, these have to be like radicals. Well, radical 3 and radical 3, that means I can add the numbers on the outside. So I'm going to add negative 24 and a positive 6. Okay? Well, that's going to be a negative 18. Okay? If you forget how to do that, we have negative 24 plus a positive 6. Okay? Well, we take the absolute values. 24 and 6. Okay? Again, signs are different, so I subtract the larger absolute from the smaller. That's 18. And then I use the original sign. I go back to the larger absolute and use its original sign, which is negative. Okay? So, that's just kind of a quick refresher of skill 2-3. All right? And then finally, we do not add radicals. Okay? That is our answer for negative 6 times the square root of 48 plus or minus negative 3 times the square root of 12. Okay? The next problem, again, we change any subtraction to addition. So this becomes a plus, that becomes a negative 5. Now we go simplify. I know my final one's going to be negative, okay? Square root of 32, not a perfect square. The largest perfect square that goes into 32 is 16. All right. Well, that's going to be, the square root of 16 is a 4. In this case, it's going to be a negative 4 because we bring that down, times the square root of 2. Okay? Again, I cannot simplify this anymore, so I move on to my next guy. I'm going to put my plus sign there because I know there's that barrier. Alright, I'm going to have 3 here. Okay, I'm looking at that 200. Very large number. Is it a perfect square? No, it is not. What's the largest perfect square that goes into 200? Well, it happens to be 100. And 100 times 2. Well, the square root of 100 is 10. Again, we use the square root on the 100 to get the 10. That's why the square root is gone. So 3 times 10 is 30 times the square root of 2. Okay? Awesome. I can't simplify that anymore, so I put in my other plus sign, which is my barrier. Well, this is a negative 5 now. I'm thinking, what can I break down 72 into? Well, 72 is not a perfect square, but 9 goes into 72. Oh, but wait, there's even a larger one, 36. Okay, so again, if you get the largest perfect square that goes into 72, it's going to be simplified right away. Okay? 36 times square root of 2. That makes us -5 times 6 times the square root of 2, which makes this -30 times the square root of 2. So, in the end, plus here, plus there. Okay? What's great about addition is the commutative property. Doesn't matter which way you order when they're all addition. Well, if I have a positive 30 here and a negative 30 here, these two are gonna cancel each other out. Okay? Because 30 minus 30 is equal to 0. Okay? So this is really 0 times the square root of 2. And we know that the 0 property of multiplication says anything times 0 is 0. So that there is equal to 0. So our final answer is -4 times the square root of 2. Okay? So, at this point in time, if you have questions, first I suggest you go back and look at the video. Maybe there's a key topic that you missed. And if that doesn't help, go ahead and raise your hand, ask me the question, and then begin working on this worksheet. Thank you.